everyone. Good evening. It's fantastic to be here at KCD today. I'm Lavanya Namburi, a Principal Cloud Native Application Engineer from Amadeus. A little bit of my background. I'm passionate about building scalable and performant backend solutions with 13 years of experience in Java. In my career, I had privilege working with some of the most notable financial institutions like Lloyds Bank, Standard Chartered Bank, and Morgan Stanley. More recently, at Amadeus, I have been deeply involved in architecting and building cloud-native applications using Quarkus, reactive programming, pipeline architecture, and microservice architecture. In fact, I made a significant contribution in building a universal API translator, which is a critical component in integrating diverse travel content. This work at Amadeus brings me to the context of today's session, unlock the full potential of Kubernetes with Quarkus. For those who might not be familiar, Amadeus is a leading technology partner that literally powers seamless travel experiences across the globe. We play a pivotal role in the travel industry by aggregating vast variety of travel content like airlines, car rentals, hotels, travel insurance providers, trains, and many more such content all behind the scenes. We at Amadeus excel in building large-scale business-critical processes and complex enterprise systems, solving some of the travel industry's most intricate problems. Our systems are built to be incredibly robust, secure, integrated, and open, earning the trust of world's leading global travel brands each and every day. The sheer scale of our operations is immense. During peak times, our applications are serving up to 1 lakh transactions per second. In comparison, it's equivalent to Google's TPS. All this capacity is highly scalable, ensuring we deliver on the ever-changing platform of the travel industry that is constantly evolving. In fact, to keep the pace with such shifting demands, we are accustomed making 15,000 system changes every month. The journey towards achieving such scale and agility is fundamentally part of our broader strategic initiatives. In fact, building upon the strategic vision shared today earlier by our department head Shubhang in his keynote session of Amadeus Cloud Migration Journey, my talk today is going to be a direct reflection of technical solutions and practical experiences emerging from such broader initiatives. Before we delve into the session, I would like to start with this little story. Before we explore the exciting world of Kubernetes and Quarkus, hear me out saying this small story. I have a close to 5-year-old wonderful daughter, and like many kids of her age, she is in that constant state of asking why. Her curiosity is boundless. She keeps asking, why sky is blue? Why do birds fly? And why is our apartment named SLS Summerfields? Why not SLS Winterfields? Trust me, her curiosity is boundless, but sometimes it is exhausting. But her endless curiosity of questioning is something that leads us to a constant or a crucial part. Actually, asking why is how we explore. Asking why is how we challenge our assumptions. Asking why is how we understand things well and deeper. It's actually a great tool that can let you explore how you can do things differently and in a better way. So that's the exact spirit that I want to bring to this session today. In this session today, we are going to explore Quarkus and Kubernetes, not just by presenting facts, but by asking some fundamental whys. So I would like to kick things off. I'm skipping the agenda for now. I would like to kick the things off by asking a question. a question that many of us, especially the Java developers and architects, might ponder behind their mind. Are we really getting the most out of our Kubernetes and cloud investments with Java? We moved to cloud. We adopted to Kubernetes. But sometimes it still feels slow, expensive, and not as cloud native as we hoped. Our aim today in this session is to explore this question and, more importantly, find some superpowers that can change the game. Let's begin. When we first moved our Java applications to the cloud, be honest, we might be having such image in our mind. We might have envisioned a sleek, efficient, rapidly scaling microservices, just like this cloud-native sports car or some rocket launching instantly. But then the reality hits. We often find our Java applications acting like this old clunky car struggling uphill and consuming resources like there is no tomorrow. These applications take ages to start, hog on memory, and they just sit there idle, hogging on memory, and scaling them efficiently feels like a constant battle. This actually leads us to a couple of interesting questions on why this is happening. Let's get curious a bit. If Kubernetes is so smart, then why do my applications, Java applications, feel so heavy on the cloud? Why do we constantly ask ourselves why my applications take so much of time to start in a new Kubernetes pod, which is impacting my scaling response? And why my application is so resource hungry? Why is it consuming so much of memory, though it is sitting idle there waiting for the request? And the big one, are we really saving money by moving to cloud when each of my application is so resource hungry and forcing us to buy bigger and more expensive machines? All these questions are valid, and they actually lead us to a couple of interesting, so I call them as costly questions, and they lead us to a fundamental challenge that the traditional Java is having for modern cloud-native environment. Traditional Java is built for long-running monolith applications, not for ephemeral, quickly scaling microservices. So everyone, say hello to Quarkus. The answer to those costly questions that we saw, and the tool that truly unlocks the full potential of Kubernetes for Java is Quarkus. Quarkus proudly calls itself as supersonic and subatomic Java. This isn't just market hype. It's a statement for purpose. Quarkus takes a fresh look at your Java applications in the Kubernetes world, in the containerized world, and it is designed from the ground up to be Kubernetes native and cloud native. It is a special framework designed on top of Java that is optimized for lower memory usage and faster startup times. Our goal today is to explore how Quarkus is different from the traditional Java and how it is cloud native or Kubernetes native. Let's first start with this. Let's try to understand what makes Quarkus supersonic and subatomic. In the cloud native world, we want our applications to start very quickly. Pods in the cloud are ephemeral. They can go down for n number of reasons. As soon as they go down, our applications should be smart enough to come up quickly so that we are available for our customers at most of the time. It directly links to the availability of your application for your best user experience. So that's where Quarkus calls itself as supersonic. All the Quarkus applications starts very quickly compared to traditional Java applications. How? We'll just look in a minute. And also it calls itself as subatomic. Traditional Java applications are, as I said, were built to be monolithic and for long-running applications. Whereas when we move to cloud, for your application to start quickly or to consume less resources, the size of your deployment should be less. It should be subatomic. So when it compared to traditional Java, the Quarkus applications are subatomic. How again? We'll look into now. Let's compare your, let's say that you are building one application and you are writing one application and you are building it with these three different models: Spring Boot Hotspot, Quarkus Hotspot, and Quarkus Graal VM. So let's start with the Spring Boot Hotspot. You can see the metrics, the build time and runtime metrics over here. With the Spring Boot Hotspot, during build time, it's just that you are compiling your Java classes using the Java compiler and generating the bytecode. That's it. That's what we are doing during the build time with the Spring Boot Hotspot. And you can see the build time here is 1 second, whereas your RSS usage is 512 MB. When it comes to the runtime, there are many steps that happens during the runtime. I'm just giving some of the most important ones over here, like the dependency injection configuration. Your JVM starts to load the classes and class paths and try to resolve the dependency injections, try to instantiate the beans for you by resolving the dependency injection and start your main thread. And then your JIT compiler comes into the picture for profiling and optimizing the frequently used code for you for quicker responses. So here the runtime is taking around 10 seconds and the RSS is 220 MB. Now let's see how is it different on the Quarkus hotspot. It's exactly doing the same thing during the build time by converting your Java code into bytecode using the Java compiler. And then the dependency injection resolution has been moved from the runtime to the build time. And you can see the build time has increased over here from 1 second to 9 seconds, and even the RSS from 512 to, it's just the same. But what happens at the runtime? As the dependency configuration moved, it's just that the JVM now has to load the state and start the socket and main thread to get your application up. It can happen in just 2.5 seconds. And even the RSS has reduced from 220 MB to 140 MB. And then your JIT compilers will kick in again to optimize or profile your code for the most commonly used part of your code. Now let's see what Quarkus Graal VM has in plate for us. It's a bit similar to what Quarkus Hotspot does. But what does our JIT compiler do? It converts your bytecode into native code. It's just zeros and ones that the machine can understand directly. I do have my dependency injection resolved here. I do have my bytecode. This dependency injection is happening on your bytecode, which would be a bit faster. And now what if I can move the compilation of the native image to the build time? And you can see the build time has drastically increased from 1 second to 4 minutes over here. But which is fine. Build time can take more. But my goal is my application has to start quickly during the runtime. Let's see. You can see here, all I have to do in the runtime is just load the image heap and start your socket main thread. And that's it. Your application is up. You can see my application is up and ready in just 50 milliseconds. It's just less than 1 second. And even the RSS size is 35 MB. When you move your dependency injection and you are building the native image during the build time, it significantly reduces your image size. It actually starts from the main thread and draws a graph and goes to all the classes that are reachable from your main thread and eliminates all the classes that are not reachable from the main thread. And that's how it makes the size of your image to be subatomic. So have we got our answers? Why Quarkus is supersonic and subatomic? Let's move on. Sometimes it's not about just speed and saving money. Of course, they are huge. There is no denial in that. But still, how about maybe we might be having a question, can the Java development be fun again? Most of us in the market are the Java developers, and we have been associated with Java from more than 3 decades now. Can the Java development be fun again? We loved Java because of its object-oriented nature compared to C and C++. Now, on top of Java, we are going to Quarkus. We are going to cloud native. Can the Java development be fun again in the cloud environment? Take it from me, the answer is a resounding yes. So, what does Quarkus offer for us? How about the Kubernetes native features or the cloud native features that comes from the Quarkus, and how it is different from the traditional Java approach is what we are going to see next now. The answer to the first question, yes, development with Quarkus, development with Java could be fun again in cloud, because Quarkus comes with features like developer joy, features like live coding, where you start your application in the development mode, you do a change, you save it, you hit the save, and that's it. You need not restart your application. The changes are loaded in your running application just in a blink of an eye. It drastically improves the iteration time. It's not just that. Let me take you to a simple demo in a while to show you the live coding part of it. But before we just go, I'll just finish the 2 parts of it, touch base the 2 parts of it in this slide. The Kubernetes native features. So Quarkus comes with the built-in Kubernetes native features, like right out of the box for you to handle your applications. I think in previous slide, I just asked you a question. If Kubernetes is so smart, then why do our Java applications still feel so heavy on the cloud? It's because the traditional Java was not built for the cloud native world. It lacks some of the features that can handle the smartness of the Kubernetes. Of course, there is no doubt that Kubernetes is so smart, but Quarkus has that features that can leverage the smartness of Kubernetes right out of the box. As a developers, we need not do anything extra out of the box to make your application Kubernetes native. So Quarkus offers these Kubernetes native features like health checks, metrics, observability, and also makes your application deployment and integration to the Kubernetes so seamless with right out of the box features. We'll look into it also. And also it comes with a rich extension ecosystem, meaning it has a lot of extensions that are readily available for any cloud native requirement that you have, ranging from security, messaging, database, you name it, they have it. Now let's look into a quick demo. So here, all I have is a simple Quarkus microservice where I have a simple REST endpoint that prints hello from Quarkus. And I started this Quarkus application in dev mode. This is one of the Quarkus out-of-the-box feature for the developers to bring that joy of coding back again. It comes with this UI, nice UI. All you have to do once your application is up is just hit the local port. You will be redirected to the dev UI. This is a very helpful one. Once you visit the dev UI, you can list down all the endpoints that your application has. It even provides the Swagger specification for each one of them. Let's hit the hello endpoint. And it is printing hello from Quarkus. Let's go see by changing the code. Hello KCD. And I'm hitting the save button. And I didn't restart my application. All I'm doing is re-hit the endpoint, and you can see the changes. So you need not stop your application or repackage it and deploy it. The changes are instantly reflected in your live running application. Now, while bootstrapping this application, I just wanted to have a feature to add products and list products to the MongoDB. I hope I have time. Okay, sorry. You can see in my application properties, all I have given is to which collection in the MongoDB I would like to save my products. But I haven't mentioned here what is the connection URL to my MongoDB. It just understood from the dependencies that are there in the pom.xml, and when I start this in the dev mode, it creates the database, the chosen database for you behind the scenes, and it makes your application link to the database by default. And you can go to your dev UI and can very well see in the dev services that it has started a MongoDB instance for you out of the box without you configuring it and making a link between your application and the DB. So it started this at this port on your laptop and has linked that application to this. Now, this is the Swagger API that comes out of the box for all the endpoints that you have defined in your Quarkus application for you. Let's post a product, maybe book. And I can click on execute. And now I'll go get the products. Now you can see pen was already there, book has been added instantly. So that's how the Quarkus brings back the developer joy for you. Let's move forward. Let's look into some of the Kubernetes native features, starting with the health check metrics. So in the world of microservices and Kubernetes, it's not enough for your applications to be just running there on the cluster. Kubernetes has to know if your application is up and running. It is so smart enough, let's say if your application is down for some reason, it stops sending the request to your application. And also, it can restart your application for if something goes wrong in some particular area. But for Kubernetes to know that something bad has happened with your application, you need to do something at your application side to let it know that I'm not ready to serve the request yet, or I'm not alive yet. So to do this in the traditional Java, it's a tedious process. But with Quarkus, it's just as simple as adding an annotation. So Quarkus comes with an extension where you have multiple annotations to support the health check and readiness. So one such annotation is liveness. You can think liveness as a heartbeat for your application, and Kubernetes will be able to access the liveness of your application at /q/health endpoint of your application. So think of it this way. If your applications runs into out of memory, or there is infinite thread blocking that is happening on your application, then your health check will fail. And that's when your Kubernetes will take a drastic decision of restarting the container for you. And that's how the liveness is used. And we do have one more annotation, @readiness. Sometimes your application is up, but it's not still ready to serve any request. Think of it this way. Your application has a dependency on the database, and the connection between your application and the database is not yet established. Your application is up, but the connection between your application and the database is not ready yet. Or your application is dependent on a third-party API, but that service is down. So in those cases, if you put that readiness checks with just @readiness annotation, Kubernetes would be able to query the readiness of your application on an endpoint, and it sees that if it is not ready yet, it will not send the request to that particular node. And the main difference between liveness and readiness is if your liveness check fails, Kubernetes will restart the pod. But if your readiness check fails, it doesn't restart the pod. It will just temporarily suspend or stop sending requests to that particular pod, and it expects your node to recover itself eventually. This is just an example of how easy to create a liveness check in the Quarkus. So it's just that you are adding @liveness annotation for your health check. And it's same for the readiness as well. Let's move on. It is not enough, again, in Kubernetes world or in the cloud native world, just to know if your application is up and running and ready to serve the request. We need more. We want to know more insights about the application, like how much memory it is consuming, how many requests are reaching, all kind of the metrics enough for us that we would like to monitor on your application. So Quarkus comes with rich extensions. Again, it has the micrometer extension that can provide metrics out of the box for you, and also it will let you write your custom metrics as well. As soon as you add this micrometer extension to your Quarkus application, all your metrics are by default available at this endpoint /q/metrics for the Kubernetes to query. And this can be, again, scraped by observability platforms like Prometheus and OpenTelemetry. One of the sample custom metric. So that's how easy to create it. So all I have to do is inject the meter registry here. And if I want to count how many number of times this endpoint is called, all I have to do is register that counter, and you give the name of your metric .increment. That's all. And if you start your application, go to /q/metrics, this metric is readily available for you. Moving on. In the cloud native world, developing an application is half of it. Deploying your application onto the cloud is where the main challenge lies. Kubernetes comes with many smart components, and few of them are your ConfigMaps and Secrets. Quarkus has out-of-the-box features that can integrate with these Kubernetes components or the configurations like ConfigMap and Secret very seamlessly for you into your Quarkus application. So what are the steps? Anybody who used Kubernetes might be knowing it's very easy to create a config map or secret on your Kubernetes cluster. Create an YAML file, run a kubectl command, that's it. It creates the config map secret for you on the cluster. Now you write a deployment file for your application where you mount these config maps and secrets for your application. And in the Quarkus application, all you have to do is inject those properties using an annotation. That's it. During the runtime, these properties are available for your application to be ready to be used. So this is a simple configuration to create a config map, where my config map name is my Quarkus config, and it has two properties, greeting and the database URL. Running a kubectl apply command will create this config map for us on the Kubernetes cluster. Now here is the deployment file for my Quarkus application, where I am trying to, inject these configurations into my runtime of my application. You can see that here we are injecting, mounting the config map, my Quarkus config map as a volume onto my container. And in the code, in your Quarkus application, all you need to do is inject this config property, myConfig, and then that's it. You have all the getters and setters that are readily available for you to access these configurations out of the box. Now, there are, as I said, n number of extensions that are available in the Quarkus for ready to use. But this one is very close to my heart, Mutiny, a reactive extension from the Quarkus that truly unlocks the power of resource utilization for you. It makes, how do I say, it is used to achieve more with less. When I say, let's say in the traditional Java or without reactive programming, you might be using more number of threads to do the same amount of work, but whereas with Mutiny, you will use very less number of threads to achieve the same work. Mutiny lets your blocking operations get executed asynchronously, and each thread will be reutilized or freed up to serve the consequent requests. In the interest of time, I'm not deep diving into the mutiny, but definitely it's worth exploring a very good extension from Quarkus. Now, what are the key takeaways for today's session? So Quarkus is built for fast startup time, and it is designed to have low memory footprint. And it gives you out-of-the-box features like health checks, metrics, and seamless configurations for your application. And also, its reactive nature helps you design your applications for less resources on the cloud. While we conclude our session, I would like to remind you all that these aren't just theoretical concepts for us at Amadeus. These are the bedrocks on which we build our applications and run our complex infrastructure that keeps world traveling. On that note, thank you.